So my favorite part about this project was working with the bipedal walker environment within the Gymnasium library for Python. This is a environment that's been built in Pygame, so the graphical interface already exists. What you do with it is to train the walker to move within the environment. The biggest takeaway that I found from it is just how complex bipedal locomotion is. This is a really simple demo. You can see it sort of there, but I'm also going to demo a larger version of it here for you so you can see it more easily. It's just a pelvis, two legs, and a knee on each leg, and that's it. This is the untrained walker. You can kind of see it just falls over, wiggles around, whatever. It doesn't know what it's doing yet. That's the untrained version of it. But that simple little walker has a variable space observation variable space of 24 variables, which mean, all the different velocities and locations of its joints, and also the LiDAR measurements. Now, the thing about the LiDAR is important because there is nothing about the environment within the code. It determines all of everything from its environment using its LiDAR. The LiDAR is the little red line you can see it spit out sometimes. So I was able to train a walker in the regular environment fairly easily, and you can see it here. I'll demo it for you. And it's supposed to score a certain number of points by covering a certain distance within a number of required number of seconds. So this one wins every time. You can see, though, that the gait that it's chosen is still to keep one leg forward all the time and kind of do this skipping motion, which was the same gait that was chosen by the Mel AI. So I thought that was really interesting to see that. But the environment for the basic walker, it's just kind of this gentle, rolling, flat line. Almost any forward locomotion option would be successful here. So I wanted to do something more interesting. So the environment also has a hardcore environment, and the hardcore environment includes things like steps, blocks, holes, and other things like that to try to trick the walker. The biggest thing I found about using the hardcore environment was that it was really easy to get stuck in a local maximum, because what would happen, and I'll demo it here, is that the walker would get scared, basically, when it encountered an obstacle and just stop. So what's happening in the background here is I'm loading the observation state. I had to add in some extra reinforcement learning rewards and punishments so that I told it that holding still like this, where the observation state remains the same for several steps in a row, is bad, and it loses points for that in addition to just losing points for tipping over. Because what's happening here is that it loses points only when it tips over and gains them when it moves forward. So what happened here was it didn't see a way to move forward and gain more points. It only saw a way to not lose points, and so it stood still so it didn't tip over. Once I adjusted that, though, I was able to get some more interesting behavior. Let's find this here and get that to go for you. Now, once again, it's chosen this one-legged hopping gait as the best way to get over obstacles, which I think is interesting. Now, it gets stuck here for a while, unfortunately. And it doesn't quite know how to defeat this obstacle. It's got to work on that. And I think the part of the problem is that the agent that I'm using, the algorithm that I'm using to train it, just isn't smart enough. I'm using the ElegantRL library, their Proximal policy optimization library, and this is a really difficult simulator to beat, even though it doesn't look it. And the PPO agent is just not smart enough to do it consistently. I'll show you here the learning curve. This is the learning curve for the regular agent, and you can see very quickly it pops up here, and the average score levels out. The average, the outliers still exist, but on average, the score levels out very quickly. alternately, I can show you the hardcore learning agent, and you can kind of see that that does not happen. And what we're getting is the outliers are increasing in value, but the average score never improves. So it's not really learning to defeat the course. I'm a perfectionist. I'm still training it. I'm trying to do better. But at this point, that's as far as I've gotten with it.